Welcome to Johnny Discovery, where we explore the fascinating world of modern agriculture across America. We're diving deep into one of the sweetest stories in farming, the journey of sugarcane. From soil to spoon, and from sprawling fields to high-tech sugar mills across the United States. Today we'll explore vast sugarcane farms in the U.S. We'll follow the farmers from planting to harvest, learn about modern farming technologies, and understand the sugar production process in factories. Let's get started. Before a single stalk of sugarcane can rise, the land must be carefully prepared. Farmers in Florida, Louisiana, and Texas, the key sugarcane growing states, start by clearing fields, plowing the soil, and testing for pH, nutrients, and organic matter. The timing of sugarcane planting varies by region. In Florida and Texas, it starts in late summer, while in Louisiana, it typically occurs between August and October. After each growing season, sugarcane fields undergo significant wear and nutrient depletion. To restore optimal growing conditions, farmers initiate a thorough soil preparation process. This begins with deep tillage, a crucial step that not only aerates the soil, but also breaks up compacted layers, enhancing both drainage and root penetration. Using high-powered tractors paired with specialized plowing equipment, farmers can till several hectares per day, transforming hardened soil into a loose, crumbly medium, ideal for sugarcane root development. Next comes the precise formation of planting rows. On large-scale sugarcane farms, straight and evenly spaced rows are essential, not only for efficient crop management, but also to accommodate mechanical harvesters. Farmers employ GPS-guided machinery to carve parallel furrows into the soil. These furrows typically follow the contour of the land to reduce erosion and maximize water retention. These furrows are more than just grooves. They're the cradles for new sugarcane life. Sugarcane is propagated using sections of mature cane stalks, known as cane sets. Each cane set is cut to a length of approximately 12 to 18 inches, containing 3 to 4 viable buds, the nodes from which new shoots and roots will emerge. These pieces are placed into the prepared furrows by a mechanized sugarcane planter, which ensures even distribution and depth. Each piece containing 3 to 4 buds is laid horizontally or slightly inclined into the furrows at a depth of 1 to 1.5 meters, depending on soil conditions. The machine then gently backfills the furrow, covering the cane sets with a layer of soil to protect them from desiccation and to maintain adequate moisture levels for germination. This mechanized process dramatically reduces labor intensity and improves planting accuracy. From the moment those buds sprout, sugarcane begins a long and steady journey of growth, typically lasting 12 to 18 months. The growth process is divided into three main stages: germination, tillering, when new shoots form, and ripening, when the cane stalks swell with juice. Sugarcane is classified as a water-intensive crop, requiring substantial moisture throughout its life cycle, especially in the first 3 months when roots and shoots are establishing themselves. Without adequate water, plant development slows dramatically, leading to reduced yields. To address this need, farmers employ a variety of modern irrigation techniques tailored to the specific topography and climate of the farm. The three most common methods include drip irrigation, sprinkler irrigation, and flood irrigation, with drip systems being the most prevalent in high-efficiency operations. Drip irrigation is widely adopted on modern sugarcane farms for its exceptional water use efficiency. This system consists of a network of main water lines branching out into smaller, flexible tubes that run alongside each row of sugarcane. Attached to these tubes are emitters, small nozzles placed at regular intervals, strategically positioned near the root zones. Installing a drip irrigation system in a sugarcane field is a smart investment in both productivity and sustainability. The process begins with careful land preparation. Farmers level the field and plow the soil to create optimal conditions for root development and water absorption. Once the field is ready, a reliable water source is connected to a powerful pump system, which channels water through a sophisticated filtration unit, which removes any impurities before the water reaches the crops. Then, main pipelines are laid out across the field, branching into thin drip lines that run alongside each row of sugarcane. Each line is equipped with small emitters that release water slowly and precisely at the root zone. No waste, no runoff. This method not only saves up to 60% of water compared to traditional methods, but also reduces weed growth, minimizes disease pressure, and enhances crop yield and quality. Another effective method, particularly in large or irregularly shaped fields, is sprinkler irrigation. In this setup, high-pressure pumps push water through pipelines to sprinkler heads spaced evenly across the field. These heads distribute water in a circular pattern, simulating rainfall. Sprinkler systems are highly adaptable and can be moved or adjusted to suit the crop's stage or field conditions. While slightly less efficient than drip systems in arid climates due to evaporation, sprinkler irrigation remains popular because it can cover vast areas quickly and uniformly. Flood irrigation is one of the oldest and most widely used methods in sugarcane farming. After preparing the field with level furrows, water is released from canals or ditches and allowed to flow across the rows, soaking the soil thoroughly. This method is simple, cost-effective, and ideal for flat terrains with abundant water supply. Though less precise than modern drip systems, flood irrigation delivers large volumes of water quickly, supporting rapid growth during the crop's early stages. When managed properly, it can still produce healthy yields with minimal infrastructure. Equally vital to sugarcane development is fertilization, as this crop requires large quantities of nutrients to support its tall stalks and dense biomass. The essential macronutrients for sugarcane include nitrogen, N, for leaf and shoot growth, phosphorus, P, for root development and early maturity, and potassium, K, for enhancing sugar content and disease resistance. In addition to water and nutrients, young sugarcane must be protected from weeds, which compete for sunlight, water, and soil nutrients. To address this challenge, farmers rely on precision herbicide application using advanced spraying equipment. By eliminating weed competition early on, farmers give sugarcane the best possible start, promoting stronger root development and more vigorous growth throughout the season. Once the sugarcane has reached full maturity, typically 10 to 16 months after planting, it enters a critical stage, harvesting. This process marks the beginning of the transformation from raw stalks into refined sugar, and it must be carried out swiftly and efficiently to preserve the crop's quality. In some areas, like Louisiana, fields are still burned before harvest to remove dry leaves and make the job more efficient. Dry leaves and weeds can cover the sugarcane stalks, obstructing machinery and slowing down the harvesting process. The fire burns off the outer leaf layer, leaving behind clean stalks and reducing the volume of unnecessary material to transport. This not only saves costs and time, but also makes the milling process at the factory more efficient, as it focuses on the sugar-rich stalks. However, this method is currently under strict regulation due to its contribution to air pollution and environmental impact. Burning sugarcane has almost disappeared because modern machines can now harvest sugarcane with minimal human intervention. Modern sugarcane harvesting is no longer the labor-intensive process it once was. Today, highly sophisticated harvesters are employed, designed to maximize yield and minimize crop loss. These machines are equipped with GPS navigation, precision cutting mechanisms, and automated cleaning systems, all working in seamless coordination. First, the sugarcane harvesters are precisely adjusted to cut as close to the ground as possible, ensuring that the entire sugar-rich stalk is harvested. As the harvester moves along the sugarcane rows, its sharp blades continuously operate, neatly cutting each cane at the base and lifting the stalks onto an automated conveyor belt. The harvester strips away the non-essential biomass, including dry leaves and leafy tops, using internal fans or rotating brushes. These byproducts are not wasted. Instead, they are returned to the field, forming a natural mulch that enhances soil fertility and moisture retention. After cleaning, the long stalks are mechanically chopped into shorter, manageable segments, usually around 30 to 50 centimeters in length. These cut sections are funneled into a storage chamber within the harvester. Once full, the machine uses an automated offloading system to transfer the chopped cane into waiting transport vehicles, typically trucks stationed along the field margins. The harvested cane is immediately loaded onto large trucks and shipped to nearby sugar mills. Why the rush? Because once cut, the cane begins to lose sugar content rapidly. Processing needs to happen fast, usually within 24 to 48 hours. As soon as the freshly harvested sugar cane arrives at the factory, the cleaning process begins swiftly to preserve the cane's natural sweetness and prepare it for juice extraction. Massive conveyors unload the cane and direct it toward high-powered washing stations. Here, powerful water jets blast away mud, leaves, and any remaining field debris. This initial cleaning is essential, not only to ensure the purity of the juice, but also to protect the crushing machines from damage caused by stones or soil. After the sugarcane is cleaned and ready, it is delivered to the crushing system inside the factory. Here, the stalks are fed into massive steel mills that press them with incredible force, extracting the sweet juice hidden within. As the canes are crushed, they release a flood of raw juice while leaving behind dry, fibrous residue known as bagasse. To ensure maximum extraction, the crushed cane goes through multiple roller sets. Water is sprayed in during this phase to rinse out every last bit of sugar from the fibers. The juice is collected below and rushed off to the next processing stage, while the leftover bagasse is whisked away, ready to be turned into biofuel or biodegradable materials. Once the raw juice is extracted from the sugarcane, it contains not only sugars but also impurities like soil particles, fibers, waxes, and organic acids. To transform this murky liquid into crystal clear syrup, the factory begins a critical purification step: lime treatment, also known as liming. In this process, the raw juice is heated to around 158 degrees Fahrenheit and then carefully mixed with milk of lime, a suspension made from calcium hydroxide. This alkaline solution helps neutralize natural acids in the juice and raises its pH level to an optimal range. As the lime reacts with impurities, it causes many of them to coagulate and form larger particles. The juice then flows into large clarifiers, where the solid particles slowly settle to the bottom as sediment, forming a thick sludge. The clarified juice, now significantly cleaner and lighter in color, is skimmed off the top and sent forward in the production line. This crucial stage not only removes unwanted materials, but also stabilizes the juice, setting the foundation for high-quality, food-grade sugar. Next comes crystallization. By adding seed crystals and carefully managing heat and vacuum pressure, the sugar in the juice begins to form into crystals. These are spun in centrifuges to separate them from molasses. After the initial extraction and crystallization, sugarcane yields raw sugar, coarse, off-white crystals that still contain impurities like molasses and natural colorants. To transform this into the pure white sugar used in kitchens and food production, a precise decolorization process is essential. First, the raw sugar is dissolved in boiling water at around 80 degrees Celsius, forming a thick syrup. This solution is then filtered through layers of sand and gravel to remove suspended solids and organic residues. However, the key step in achieving the brilliant whiteness lies in activated carbon treatment. The syrup is passed through columns filled with activated carbon, a highly porous material that absorbs color pigments, polyphenols, and residual impurities through physical attraction. Once the solution is nearly colorless, it undergoes another round of evaporation and controlled crystallization. The resulting sugar crystals are then spun in high-speed centrifuges to separate them from the remaining liquid and eliminate any lingering color or moisture. The final product is clean, dry, and sparkling white sugar with over 99.9% sucrose purity, ready to be packaged for consumers. This entire process, from raw syrup to refined sugar, reflects a seamless blend of modern engineering and food science, ensuring not only visual appeal but also consistent quality and safety in every grain. Sugar is packaged in a variety of formats, each tailored to fit different needs and uses. Large industrial sacks, ranging from 25 kilograms to over a ton, are commonly used in factories, commercial kitchens, and for export. Medium-sized bags, usually between 1 to 5 kilograms, are the go-to option for households, ideal for everyday cooking and baking. Meanwhile, mini-sized sachets are perfect for cafes, restaurants, and on-the-go use. After the juice is extracted from sugarcane, what remains is a fibrous byproduct known as bagasse. Rather than being discarded, this material is now recognized for its exceptional versatility, especially in the production of biodegradable alternatives to plastic. Bagasse is first thoroughly cleaned to eliminate residual sugars and impurities, then mechanically and thermally processed into a soft, moldable pulp. This pulp is poured into high-pressure molds to form durable and compostable items such as plates, bowls, cups, and takeout containers. These products not only serve as eco-friendly alternatives to single-use plastics, but are also fully biodegradable and compostable, often breaking down within 60 to 90 days under industrial composting conditions. This innovation contributes significantly to reducing the environmental footprint of food packaging. Beyond its environmental role, sugarcane bagasse also plays an important part in agriculture as a source of livestock feed, particularly for cattle. In its raw form, bagasse is coarse and indigestible, but when fermented, much like silage made from corn, it becomes a palatable and nutritious feed. For farmers, using fermented bagasse reduces dependency on conventional feeds and lowers overall feed costs, making it a practical and sustainable solution in livestock management. In both environmental and agricultural contexts, sugarcane bagasse exemplifies how agricultural byproducts can be transformed into valuable, sustainable resources. The U.S. might not be the top global producer of sugarcane, but it's one of the most efficient and environmentally conscious. Florida alone produces over 2 million tons of raw sugar annually. The industry contributes billions of dollars to local economies and supports thousands of American jobs. If you enjoyed this deep dive into sugarcane farming and production, don't forget to like, share, and subscribe to Johnny Discovery. Join us next time as we uncover more behind-the-scenes stories from the world of agriculture.